Alright, so in this video I'm going to talk about glycolysis, which is lysing of glucose. Glucose is sugar, which has six carbons, and it's claved into two free carbon molecules. The free carbon molecule is called pyruvate. So how does a molecule of glucose look like? So this is a molecule of glucose. Alright, so this is very simplified, so we will go through the exact process right now. So let me roll it. So this is the process of glycolysis, and we are going to begin by glucose, which is the 6-carbon sugar, and we need to activate it somehow. So in this case, the activation is by ATP, which forfeits one of the phosphate and creates ADP, and this phosphate is attached to this molecule here. Alright, so we have the glucose activated, but it's not everything that we need to do with it. The next reaction is catalyzed by enzyme called Isomerase, which comes here, and basically it creates fructose out of glucose. So they're both 6-carbon sugars, but the 3D layout of the molecule is quite different. Basically, we're taking this carbon and OH group and sticking it out of the molecule, and basically what it happens that this carbon right here connects with the oxygen here. So this group right here is basically doing this. So now we need to activate it quite a bit more. So we are using another ATP to attach here. So what happens now is that we basically clave the molecule in half, just for better imagination of the process, and we are creating two products. The first product is glyceraldehyde free phosphate, and the second one is dihydroxyacetone phosphate. They're both free carbon molecules. You can see 3 carbons in here. And we know that the final product of glycolysis is also 3 carbon, so we're good to go. So here we have the equilibratory reaction, but we shouldn't forget that glyceraldehyde phosphate is reacting furthermore here, so we're getting rid of it, so the equilibrium shifts in this direction quite a bit more. So from now on we have to account every product to be there twice, because we have two products right here. In the next reaction, glyceraldehyde phosphate is being oxidized. So basically it means that it loses this hydrogen right here, and it loses it to NAD plus, which is reduced to NADH plus H plus, okay? So the glyceraldehyde phosphate is oxidized, and it also gains an anorganic phosphate, which comes right here. So this is the phosphate molecule, and it is attached from now on here. And this bond is a macroergic bond, which has more energy than the others, and this energy will be used later on. So next reaction is dephosphorylation. So what happens is that basically here comes ADP, and it tears apart or tears away this molecule of phosphate, and it creates ATP, and we are left with O minus right here in a product that's called 3-phosphoglycerate. The next reaction is again catalyzed by enzyme isomerase. This phosphate group relocates here, and it's the only thing that happens in here, very simplified, and it creates 2-phosphoglycerate. The next reaction is dehydratation. So dehydratation, and in this reaction we're getting rid of this molecule right here and this hydrogen right here. They're no longer here, as we can see, and they're forming molecule of H2O. And there is this double bond that's formed here in a product called phosphoenol pyruvate. In the final reaction of glycolysis, it's also dephosphorylation. So we have dephosphorylation again. And we have here ADP, which tears away the phosphate right here and creates the final molecule, which is pyruvate. However, we can see that we have here another molecule called lactate. So when we get the lactate, or where it occurs, so basically this process that we just gone through only happens when the cell has enough oxygen. When there is no oxygen, or where there is not enough oxygen, lactate is created by reducing pyruvate, because the body has to get rid of it. And so we reduce pyruvate by using NADH, which then creates NAD+. So when there is no oxygen and we have to go through the process of anaerobic glycolysis, all the NADH that we create through the glycolysis is then used. So there is no profit in NADH. Alright, so what do we gain per one glucose molecule? So per one glucose molecule we gain 2 pyruvates, 2 molecules of ATP, and if we are talking about aerobic glycolysis, we get 2 NADH. So just to make it clear, here we are using ATP, so we're losing one molecule. Here we're also using ATP, so we are using another molecule, so we lose it. Here we gain 2 NADH, so we gain 2 NADH. And finally here we gain our first 2 molecules of ATP, because everything happens twice from this moment. Everything happened twice. We gain 2 ATP, and right here we gain another 2 ATP. So at the beginning we are minus 2 ATP, but in the process of glycolysis we gained 4 ATP, so we gain 2 ATP net. Now we have to discuss what happens with the molecule of pyruvate after a glycolysis. So we have the molecule of pyruvate right here, and what happens is that it has to lose one carbon in order to form an acetyl coenzyme A, which we know that it has two carbons in it. So logically we have to lose one carbon in here. So this molecule at the top is very familiar to us, and it's basically cut away and it creates a molecule of carbon dioxide. So carbon dioxide goes away in this reaction, and into the reaction comes in the coenzyme A that is now attached to the leftover from pyruvate. So I'm going to draw the leftover from pyruvate a little bit differently now. And as we can see, the molecule of coenzyme A is being attached to the acetyl via this atom of sulfur. And from this, we now get the molecule of acetyl coenzyme A, and this molecule is further used in Krebs cycle.